Hey guys, it's Miss Casbera. This is the normal distribution, and it's got everything about the normal distribution curve. Right here, what we're talking about is a bell curve, even in the middle, and it starts at our mean. That's where the middle of this thing is. In fact, in the normal curve, the mean and the median are the same thing. That's one of the characteristics that it's in the normal curve. Now, this thing right here is your standard deviation. And you guys remember when you got it on your calculator. Come on. Let's see. Stat. Calc. There we go. Your mean was here, and your standard deviation is here. So, what this thing is meaning is that your mean in the middle, on this we're looking at, is 17. And then our standard deviation that we got there was 9.2. So each of their 9.2. That was at the top of the list, and that was right at the bottom of the list. But that's what this means is you've got your 17 plus 9.2 right here, then 17 plus 2 of these 9.2s, and then 17 plus 3 of these 9.2s. Okay, so really, if you're adding them up, this first one is 26.2, and then we add another 9.2 to it, and you get 35.4, and you add another 9.2 to it, and you get 44.6. On the other side, what you've got is 17 minus 9 is 8.8. Sorry, 7.8. We actually wasn't well thought out of me here. Are going to run out of stuff. You normally have plenty of ways to do this and not end up in the negatives like I am. But 17, let's see, 0.8, that is actually 16 minus 9 is 7, like I said. Okay, 7.8. And then minus 9.2 is negative 1.4. And then minus 9.2 is negative 10.6. So, that's what it's meaning when you've got these symbols here. Hopefully it'll be a little bit easier than that. But, here we go. Explain exactly what I just did. And the average healing time of a certain type of incision is 240 hours with a standard deviation of 20. So you've got a mean of 240 and your standard deviation is 20. So here's 240 plus 20 gives you the 260, plus another 20 gives you the 280, plus another 20 gives you the 300. These are all subtracting 20 off. Okay? So that's all you're doing right now is just setting up your normal curve. Your mean and your median will be here. Your biggest set of values is right there. And they taper off at the ends. Okay, so here is one that doesn't have it filled in for you. The weight of a box of cereal averages 565 grams with a standard deviation of 5 grams. So you have your normal curve with the middle high, and that is going to be the 565. One standard deviation above means add 5, which is 570. The next one, add another 5, which is 575. And the third, add 5, which is 580. On the other side, you will subtract 5, which is 560. Subtract 5, which is 555. And subtract another 5, which is 550. So that's 3 standard deviations from the mean. This is 2 standard deviations from the mean. And each of these, you've got 1 standard deviation away from the mean on either side, 2 on either side, and 3 on either side. Okay. So here are your 3 big things that you need to know. About 68.3% of the data are within 1 standard deviation of the mean. I think on the ones that we'd had, they had just been using 68%. Some places also use 68.2%. So I've had just the regular 68%. I've seen the 68.3 and the 68.2. About 95.5% are within 2. And I think the stuff that you had been using just used the 95%. They didn't use the 95.5. 99.7% are within 3. So once you get out here, most of your data is already covered. You've got that much data involved. Okay, so this is the normal curve from example 1. It shows the mean healing time of 240 hours with a standard deviation of 20. Suppose a hospital has treated 2,000 patients in the past 5 years having this type of incision. Estimate how many patients healed within each of the following intervals. I put these percentages up here for you because that's what you're doing. If they are between 220 and 260, that is your 68.3%. Okay? If they are between the 200 and the 280, that's where you get your 95.5%. Okay? If you have between the 180 and the 300, that's where you have your 99.7%. So this is actually 68.3% of 2,000. And remember, of is always your multiplication. So, let's pull this up. And point 683 times 2,000 means that 1,366 people were healed there. Were healed within 1 standard deviation. Okay. The next one is 95.5%. So you would, Alright, so you would multiply by 0.955%. 0.955 times 2,000. That's 1910. So we're getting very close to the 2,000. 1,910 out of 2,000 patients. And the last one is 0.997. So you have 0.997 times the 2,000 people. That's 1994. So there are only 6 people at that point that don't fall under this healing curve from having that type of incision. All right. So we did the same thing here. 1 standard deviation, back where we had our 1 standard deviation, 2 standard deviations, and 3 standard deviations. And this was the same thing right here. 68.3%, 95.5%, and 99.7%. So out of 6,000 boxes, how many boxes fall within each of the following intervals? This would be something that would need to come in as an assignment, and I'll finish this up in a little bit.